All right, try it 1.57. Another one of these problems where you're trying to find the inverse function for a function that has a radical in it, a square root. It's really an even radical where this ends up being an even root, where this ends up being an issue. So what you can do is you can start out going at this thing kind of naively. You can say y equals 2 minus the square root of x. And the way I like to do it is now switch my x's and my y's. So I got x equals 2 minus the square root of y. And then solve this thing for y. So maybe I'll add the square root of y over to the left side of the equation. And then subtract x over to the right side of the equation. And then if I square both sides, I get y equals 2 minus x squared. In other words, f inverse of x equals 2 minus x squared. But you have to be careful here. And you'll have to be careful anytime you're dealing with radical functions like this. It's not enough to say that this is the inverse of this function. In fact, it's not the inverse of this function. You can put numbers into this and get outputs where that input-output pair will not be congruent with an output-input pair from the function. If you don't know what the hell I'm talking about, go back to the video on example 1.84, read through this. Okay, so what do? Well, really what you need to do is figure out what is the range of your function right here. And the range of this function should be the domain of this function. You have to restrict the domain of this function to whatever the range of this function is right here. It turns out that the range of this function is all values less than or equal to 0. That's not even true, shoot. Is all values less than or equal to 2. Yeah, that's true. How did I come up with that, or how did I screw it up in the first place? Well, I think it's easiest to figure out the range of this function by graphing it. So I can graph this if, think about f of x equals the negative of the square root of x plus 2. This is just transformations of my toolkit function, f of x equals x squared. This negative, I'm going to take all of the y coordinates and multiply them by -1. And then this plus 2, I'm going to shift all of the heights. I'm going to add 2 to all of the y coordinates. And I do the multiplication before the addition. So this height was 0. 0 times -1, it's still 0. Add 2 to it, it's going to go up here. This height right here was 1. 1 times -1 is -1. Add 2 to it. Coincidentally, it ends up here. This height right here was 2. 2 times -1 is -2. Add 2 to -2, you'll get 0. That point goes right here. What you end up with, maybe in a different color, is a graph that looks something, that's a horrible picture of it, but something like this. This is f of x here. And so if you look at this thing, what possible heights can come out of this function? Well, 2 can come out of this function as a height, as can any number less than 2. But no numbers greater than 2 can possibly come out of this graph shown in green right here. So the range of f is everything from -infinity up to 2. So if this is the range of f, then this has to be the domain. So domain of f inverse is everything from -infinity to +2, including +2. That's what I wrote right here. My value of x has to be less than or equal to 2. This is the inequality way of writing this in interval notation. So this entire thing right here would be my inverse function. I know it might seem a little bit picky to have to add this in there, but you really do need to add this in here if you want to have the inverse of the original function. One last thing, I don't know how relevant it is, but your book asks you to state the domain of both the function and the inverse function. Stating the domain of the inverse function is super important. That's what I did right here. Stating the domain of the function, sure, I guess I can do that. I don't know how relevant it is in terms of the inverse function, but just FYI, since we're here, the domain of f is all numbers greater than or equal to 0. And the way I figured that out is going back to section 1.1 stuff. My rules for domain at this point in your algebraic progression is you can't take the square root or any even root of a negative number, and you can't divide by 0. No division going on here, so I don't have to worry about dividing by 0. But I could take the square root of a negative number if this thing in the radicand, this x right here, were not greater than or equal to 0. So I need to ensure that this x right here is greater than or equal to 0, which is what I'm stating right here. That's the domain of the function, which again really isn't all that relevant to the inverse function. What's relevant